Hi everyone. If you are learning machine learning, MLOps or GenAI, at some point you will hear this question often. How do I track experiments properly? How do I manage models, parameters and metrics? And if you are dealing with LLM, then how do I manage prompts? That is exactly what this video is about. In this complete end-to-end session, I'll walk you through MLflow, not as isolated features, but as a real system that is used in modern MLOps and LLMOps workflow. This is mostly practical working understanding kind of video. You won't be looking at too much theory except for the first video. And across this video, you will see how MLflow is used for experiment tracking, parameters and metric logging, model versioning and lifecycle, MLOps workflow, and then there will be LLM ops as well, like how do I manage prompts, how do I load prompts, how do I evaluate prompts and things like that. If you are a student, a working ML engineer or someone transitioning into ML ops or GenAI, this video will give you a solid mental model of how MLflow actually fits into real projects. You don't need to watch everything in one go. Treat this like a reference guide you can come back to. Now let's get started and build a clear understanding of MLflow from the ground up. Hello everyone. In this video, we are going to discuss about the most important and fundamental step before we actually begin, doing hands-on with MLflow. And that is why ML systems need experiment tracking beyond notebooks and Gits. So let's get started. So I have not made these presentation slides very text heavy because I wanted to give you the gist of why MLflow exists without drowning into too much details. Okay, so here if you see this diagram, this on the left represents a mess and this on the right represents something which is ordered and connected, and it has some connections. So we are saying this as from ad hoc experiments to production ML systems. So before we actually dive into anything of that sort, we are going to talk about how most MLflow projects start. So usually, if you have built a machine learning model, you start with a Jupyter notebook. Okay, so that is one notebook, and you will have one data set. It could be locally downloaded in your laptop or in your compute instance, whichever you are using, or it could be very small data set. Okay, it could be a large data set or small data set, or it could be present in a cloud repository or in your local notebook where your notebook instance is running. Now there is one model also. Initially, at least you will have one model. You won't be doing much experimentation and fine tuning, that sort of thing, and one person. And for most of the people, this is fine. And if let's say you are into academic and you are doing some sort of research where you have not more than maybe one or two people, in those scenarios, I don't think MLflow should be used also, because it's like wasting more time on these tools if you don't have that much requirement. Okay, so let's move on. Now I have basically given some naming convention that people usually use in their initial stages of machine learning experimentation. They will have some sort of naming for their notebook. They will have some sort of model naming, the model that they trained and that they think is the best. Not think, but based on the metrics, they think they have come to this conclusion that this is the model which is best. And there's a lot of confusion here. Why I'm saying this is a confusion? Because you might be working in an organization where some 10-20 data scientists also exist, and in those scenarios they will have their own mess. Okay, and if you have to communicate effectively, you won't be able to and you can't trust your memory here. So that's where the confusion exists. And this is where my next slide points to the hidden assumption. We humans tend to overestimate our power to remember. We say, I'll remember how this model was created, but this does not always happen. We always forget. You have to trust your experience, not your mind, because your experience tells you that you forget, but your mind will tell you, no, I'll remember. I don't have to write it down. Okay. So, what is the difference between machine learning and traditional software building? In traditional software building, you have something which is known as deterministic outputs. You have a given piece of code that will result in a given artifact or given deployment, but that is fixed. But in machine learning, the outcomes are probabilistic in nature because we are dealing with data and randomness here. So that is why here the meaning of version differs from software building. In traditional software, we have version of code, but here version means something close to decision history. So you have got a different set of tuning parameters, hyperparameters that you can tweak a little bit, and then your result will be drastically different. So those parameters have to be logged. Now, what is an ML experiment? What is an experiment? So you can think of experiment as some sort of encapsulation of all these 5 components. These 5 components are code. Obviously, without code, you can't train. You will have data. You will have parameters. You will have randomness, and there is this fifth point which I think most people overlook, and that is environment, because you must be using some sort of packages in your training experiments. So that environment also has to be considered as a part of ML experiment. Okay, so these 5 things will create your experiment. Now, what Git captures and what Git cannot capture. So Git only captures code changes, and that is why we are talking about something different than what traditional Git offers for machine learning systems and experiment tracking. Now, why notebooks don't scale? They don't scale because, first of all, the most primary reason is that there is no structured metadata. So you uh, run things line by line, cell by cell, and you don't have a track of how many models you have trained within one notebook or across several different notebooks. You don't have a inherent execution order. Okay, no structured metadata, and there is very it is very hard to compare runs. Runs means within an experiment you can have multiple runs. We'll talk about that in maybe later videos. So what is a core problem? Core problem is that ML systems lose this decision history, and this decision history is what we are trying to capture using MLflow. Now, why this becomes a dangerous thing in production? Because production requires us to train our model again and again. Why? Because data changes, team changes, and a new person comes. That new person probably wants to reproduce what the old person has created. And not only that, your infrastructure will also change. You might be working in GCP right now, but you will have to, let's say, switch to Azure. Those things are not in your control because management can decide to change these things at any moment. So every production team must answer why a given model is in production. We should be clearly able to articulate why a given model is uh, is is basically pushed to production. What is the reason for that? Maybe its accuracy is changed, but maybe its accuracy is best. But just answering that its accuracy is best is not enough, because you will have to answer a lot of different things. Okay, so what happens without tracking? So you don't have reproducibility, you don't have auditability. Now this is very important because in a tight organization, when I say tight, what I mean is where these compliance checks are very heavily enforced, in those type of organizations, auditability is something that needs to be taken very seriously. So so this particular thing cannot be achieved without tracking. Okay, you can't audit through a notebook. Okay, no safe rollbacks. Let's say if you have a model in production and if you would like to uh, go to some other previous healthy version, you can't do that. Obviously you can do that, but there are manual things that you would like to you would have to do. Okay, so now some of the excuses of not applying these principles of ML ops and ML flow are as follows. We will clean up our code later. The code which exists in notebook, we are going to clean up it later. They will say this is just a research, and I feel this excuse can be taken if, let's say, you have a single person team and you don't have much organization and collaboration. Then I think that's fine. Tracking slows us down. Tracking will never slow you down. Tracking will only enhance your future productivity. So those things are some of the common early stage excuses that people make. Now what breaks? We all know folder based tracking, where we, let's say, create a folder for, let's say, something like experiment this. Maybe we are testing a new feature within our training pipeline, so we'll create a new folder for that experiment. We'll create a spreadsheet comparison. That also does not work. And we sometimes also make memory based decision because we overestimate our power of memory. Okay, so essentially this is a systems and discipline problem, and this problem is actually a problem when we are dealing with a organization which is very involved in compliance checks, and it's a huge organization having multiple data scientists and multiple people working on a problem. So what experiment tracking actually solves? So there are few things that experiment tracking can help you with. First is decision traceability. You can trace what led to a given decision. For example, what led to a model being pushed to production. You have got systems memory, team alignment, and production safety. So how it leads to team alignment? Because everybody is aligned on, let's say, a given model being pushed to production. They know why it is so. They can clearly go into a centralized tool such as MLflow server, which we are going to talk about later, and clearly see why a given model has been pushed into production. Okay, so yeah, okay, so now I think that would be it for this particular video. There in this video I just wanted to basically uh, give you an motivation to use MLflow within your organization setup. And we won't be doing any MLflow APIs and UI walkthrough just yet. We'll be doing that maybe in next video. But yeah, that was the intent of this video. I hope you liked it. I'll see you in the next video. Thank you so much. Hi everyone. In the last video, we discussed why it is important to consider using ML ops, or in particular MLflow, in your machine learning projects and systems. Now in this video, assuming that you are satisfied with the reasoning that I gave you and ready to basically work with MLflow, in this video we are going to be setting up MLflow within our local system, that is laptop. But you can reproduce these steps to basically run it even in your cloud environments. In cloud environments, you would have to do extra step to configure the UI part, because here in laptop I can simply run a local server and open localhost to get started with UI. But in cloud, let's say if you are working with cloud shell, there you would have to, maybe depending upon which cloud platform you are working with, you would have to do some extra step to enable that UI. So let's get started. What I'll do is I've created a separate folder, MLflow YouTube. Now within this folder, I will create my demonstration, all the scripts that I will be using for demonstration. Okay. So let me do one thing. Let me open terminal, and in this terminal, what I'll do is I'll first of all navigate into documents and then MLflow YouTube. Okay. And in here, I can open my Visual Studio Code. Okay. So we are now in the Visual Studio Code. I won't be using any AI help in this video, but I will be copying a lot of code from the documentation of MLflow. So let's get started. So first of all, I would like to, maybe I will use its own Visual Studio Code's terminal, and let's create a virtual environment here. Okay, so I will do something like okay, so we have Python installed. You would have to make sure that Python is installed on your system. So I have Python 3.11.2, and I'm actually using venv to work with multiple versions of Python. So if I do Python 3, I'm getting this, but I can also, one second, get other versions using venv. That I won't be covering and boring you in this video. So what I'll do is I'll create a virtual environment here in this directory using this name. Okay, so now what I'll do is I'll activate this source, then bin and activate. Okay, so our virtual environment has been activated. Let's quickly install the MLflow package. It would take a couple of seconds. It should not take much time. And meanwhile, what I can do is I can come here on the documentation and I can go on quick start and I can copy this. Maybe what I'll do is I'll just copy this script, or I'm hesitant in copying, but let's create a lecture1.py. Okay, inside here I will import MLflow. Okay, currently it's not using my local VNV. That is why you see these curly lines, but that should be fine for now. Now, after this, after basically accessing this, the first step is to set the experiment. I will name my experiment as maybe something like, I don't know, a demo experiment. Okay, and then I can run this script. Okay, so first of all, I will say Python lecture1.py. It should do nothing, I guess, at this point. But you will see bunch of things getting created here. It will take some time. Let's wait. Okay, so you see this, a new directory called MLruns is getting created. But here, nothing else happened, right? But let's start a, so basically when you install MLflow, what happens is you get a command line tool with the name MLflow. So if you run this MLflow, you see all these options to work with MLflow's commands. So MLflow server, and you will see all the commands related to server, but it started the server on the default port. So let's open the server now. 127. Okay, so I'm getting this server. You see these tabs: home, experiments, models, prompts. Because now earlier in the earlier days of MLflow was used only for traditional machine learning, but nowadays it has been used for GenAI based experiments as well. So you see these prompts here. So if I come here in the experiments, you see my demo experiment. If I click on it, 1 second. It's asking me because it's my first time I'm visiting this dashboard. I'll just confirm this. Okay. So yeah, so this is what I wanted to show. Now this server will continue running. We'll talk about this ML runs directory in a moment. Okay, so I hope you understood what I wanted to demo in this video. Now we are set up with the MLflow. In the next video, we'll be creating our first brand new experiment, and also in that experiment, we'll be creating a new run. Okay, so thank you so much for watching this video. Have a nice day. Hello everyone. In this video, we are going to create our first experiment, and also within that experiment, we are going to create bunch of runs. I hope you are excited. Let's get started. Okay, so we already have this code, but let me create a new file for lecture 2.py. Within this, I'll just copy this and paste it right here. Okay, now that this set experiment is basically called here, anything that I call after this line will be logged within this experiment. Okay, how do I create a run within this experiment? Since experiment has already been created, what I can do is I can start with the MLflow dot start run. Now this start run will create a context, and within this context I can do some sort of logging. But for now, let's keep it very simple, and I will log, let's say, log params. I'm calling this function log params, and let's pass dictionary here. Maybe I have a hyperparameter. Hi everyone. In the last video, we discussed why it is important to consider using MLOps, or in particular MLflow, in your machine learning projects and systems. Now in this video, assuming that you are satisfied with the reasoning that I gave you and ready to basically work with MLflow, in this video we are going to be setting up MLflow within our local system, that is laptop, but you can reproduce these steps to basically run it even in your cloud environments. In cloud environments, you would have to do extra step to configure the UI part, because here in laptop I can simply run a local server and open localhost to get started with UI. But in cloud, let's say if you are working with cloud shell, there you would have to, maybe depending upon which cloud platform you are working with, you would have to do some extra step to enable that UI. So let's get started. What I'll do is I've created a separate folder, MLflow YouTube. Now within this folder, I will create my demonstration, all the scripts that I will be using for demonstration. Okay, so let me do one thing. Let me open terminal, and in this terminal, what I'll do is I'll first of all navigate into documents and then MLflow YouTube. Okay, and in here I can open my Visual Studio Code. Okay, so we are now in the Visual Studio Code. I won't be using any AI help in this video, but I will be copying a lot of code from the documentation of MLflow. So let's get started. So first of all, I would like to, maybe I will use its own Visual Studio Code's terminal, and let's create a virtual environment here. Okay, so I will do something like okay, so we have Python installed. You would have to make sure that Python is installed on your system. So I have Python 3.11.2, and I'm actually using venv to work with multiple versions of Python. So if I do Python 3, I'm getting this, but I can also, one second, get other versions using venv. That I won't be covering and boring you in this video. So what I'll do is I'll create a virtual environment here in this directory using this name. Okay, so now what I'll do is I'll activate this source, then bin and activate. Okay, so our virtual environment has been activated. Let's quickly install the MLflow package. It would take a couple of seconds. It should not take much time. And meanwhile, what I can do is I can come here on the documentation and I can go on quick start and I can copy this. Maybe what I'll do is I'll just copy this script, or I'm hesitant in copying, but let's create a lecture1.py. Okay, inside here I will import MLflow. Okay, currently it's not using my local VNV. That is why you see these curly lines, but that should be fine for now. Now, after this, after basically accessing this, the first step is to set the experiment. I will name my experiment as maybe something like, I don't know, a demo experiment. Okay, and then I can run this script. Okay, so first of all, I will say Python lecture1.py. It should do nothing, I guess, at this point. But you will see bunch of things getting created here. It will take some time. Let's wait. Okay. So you see this, a new directory called MLruns is getting created. But here, nothing else happened, right? But let's start a... So basically, when you install MLflow, what happens is you get a command line tool with the name MLflow. So if you run this MLflow, you see all these options to work with MLflow's commands. So MLflow server, and you will see all the commands related to server, but it started the server on the default port. So let's open the server now. 127. Okay, so I'm getting this server. You see these tabs: home, experiments, models, prompts. Because now earlier in the earlier days of MLflow was used only for traditional machine learning, but nowadays it has been used for GenAI based experiments as well. So you see these prompts here. So if I come here in the experiments, you see my demo experiment. If I click on it, 1 second, it's asking me because it's my first time I'm visiting this dashboard. I'll just confirm this. Okay, so yeah, so this is what I wanted to show. Now this server will continue running. We'll talk about this MLruns directory in a moment. Okay, so I hope you understood what I wanted to demo in this video. Now we are set up with the MLflow. In the next video, we'll be creating our first brand new experiment, and also in that experiment we'll be creating a new run. Okay, so thank you so much for watching this video. Have a nice day. Dot I will try to create a new run here. Okay, all right, so MLflow dot run name test artifact, and in place of parameters I would like to log artifact, and here I want to pass the artifact path, but let's, for the sake of demonstration, log the lecture1.py file, and let's run this really quickly. Lecture2.py. Let's see what happens. So it's run. Now let's look at the test artifact in the demo experiment. So in the test artifact, if you see artifacts, I have got this test.py. So this entire test.py got created. Now if I open MLruns, you see certain structure is being followed. What is this structure? So let's go and find out. So in the MLruns, you have got this folder for one corresponds to the experiment name, experiment ID, sorry. So this one, and in fact you can see it here also. In the one is for experiment ID. What is this 60? 60 stands for the run ID. So if I go to the test artifact again, so run ID is this 60. What is this artifacts? Artifacts is, as the name suggests, is it's for saving the artifact and the actual artifact. I can use it to save pickle files. I can use it to save images, data sets, anything that you can think of that should not be saved in a DB. Now let's see what exists within the MLflow.db. So let's explore. Let me close this out and let's explore. Not here. One second. Explore DB. Explore db.py. Okay, so this DB we can connect using SQLite. So import SQLite 3, and here what we need to do is we need to create a connection. Now how can I create the connection? I can simply write something like connection is equal to SQLite dot connect. In the connect, I can pass the name of this database that is created locally. Connection is equal to this. Now this connection, I can extract all the tables. So let's also import pandas for this demonstration. Pandas as PD. And here PD dot read SQL query. And here I will say something like select name from SQLite master where type is equal to, I will put it inside single quotes. In the single quotes I will write table. So I want to get all the tables and I would like to close this. Now this is the query, and what is the database? I will just pass the connection, and let's try to print the tables and let's see what do we get. So what is exactly stored in here? Okay, so you see there are like lot of details which are there, for example score versions, evaluation data sets, and things like that. Let's try to explore one of these tables. Let me see which table can we explore. So we have got runs table. This is what I am interested in. So now I will say runs df is equal to pd dot read SQL query select star. I would like to select all the things from runs. I would like to close this query and I would like to call it on connection. And now let's print the head of this runs df dot head. Okay, so let's run this now. Okay, you see this run UUID. Now what is this UUID? But let's for the time being remove all. Let's try to print all the values, and you see 60. This 60 is the run that I actually created just now. So I hope you are able to see why what is the objective of this. Let's also try to print columns. So you see run UUID, name, source name, entry point name, user ID, all these details are logged here. Okay, so now whatever I have explained just now, there is a technical name for both of these. This store that I'm using to store the artifact is known as artifact store. Okay, this database that I'm using to store all the parameters metrics is known as backend store. Okay, and then this server that I'm running here, it's called tracking server with its UI also. So UI plus this service that is serving this server is known as tracking server. So these three are one of the important concepts that you have to remember while using MLflow. Now the next question arises that is it advisable to store these artifacts within your local setup? No, it is not. In fact, what we do is we store these artifacts in some object storage which exists in various cloud providers like S3 or maybe GCP storage bucket, etc. And the same goes for this backend store. This backend store we can go for Postgres or SQL server, MySQL server, anything that you can get access of. Now, how can we actually configure that? That is a topic of another discussion that I can probably have later, not right now. Okay. So I hope you have been able to understand what I wanted to show you. The primary thing that you have to take away from this video is that ML runs directory stores your artifacts, MLflow.db stores your metadata and run properties. Thank you so much. I'll see you in the next video. Hi everyone. In the previous video, we discussed about what this ML runs directory points to and what does this MLflow.db contains. And we were able to understand that MLflow.db is nothing but a database referencing all the metadata, tags, and run history, whatever we create during the run. In the ML runs, we can log any artifact that would traditionally the database will not be able to hold. Although we can store it in binary format, but the idea is that backend store, or rather I should say artifact store, should be used for something heavy, such as your pickle files, datasets, anything of that sort. In this video, I would like to take a moment to discuss a list of comprehensive items that you can potentially log during a run. So let's get started. So I'll create a new file called lecture4.py. Let's import MLflow. And inside this, I would like to set the experiment MLflow.set experiment, and I would like to call this experiment as YouTube tutorial. Okay. What's better to call an experiment than to call it YouTube tutorial? Okay. All right. So after setting this experiment, what is the next thing that we want to do? We would like to create a run, right? Start run. And let me create a run name. And run name I'm going to call as maybe, I don't know, I can call it as logging demo. Okay. Now, what are the different things we can log? First of all, I can log parameters. And there are two ways to log parameters: key value parameters and a dictionary parameter. So naturally, it exposes two methods to log these two. I can say something like log MLflow.log params. I can call log param and I can provide the key. So for example, I would like to log learning rate of my machine learning algorithm. Let's set it as 0.03. And I can log learning rate, maybe epoch, and epoch can be 100. Okay, so this is log params, sorry. And then there is a method by which you can have a parameters dictionary, and inside this dictionary you can have learning rate. Maybe I'll keep it as 1, 0.04, and then epoch 1. And the epoch 1 can point to 200. Now I can log this entire dictionary in a single shot by doing log params, and inside the params I can pass parameters. Now let's view the output really quickly. I would like to run this script, and I would like to also capture its run ID, so I can reference this at a later stage. Okay, let's first, and I would like to also test whether I can specify run ID or not. Let's test it out. Maybe I can specify a run ID of 123. I have not tested it because I got this idea just right now, whether we can provide a custom run ID or not. I feel it should not happen, but let's see. Okay, so run with run ID. Okay, it assumes that if you provide a run ID, it will start looking for it. So let's first create a run. Okay, so it's successful. Now what I can do is, okay, YouTube tutorial, and in this we have got logging demo, and inside here you can see learning rate, epoch, learning rate 1 and epoch 1. Okay, so we have got this ready, but now I would like to capture this run ID, and I would like to get this here because I want to demo this within the same run. I don't want to create unnecessary runs. Naturally, after parameters, we can have metrics, and inside metrics also this is a similar pattern. We can let me show you MLflow.log metric, and it's like a key value pair. Maybe I can log a accuracy, and accuracy could be something like 90%, and I could also do something like log metrics, and this log metrics could be a dictionary. And here what we can do is we can define a metrics dictionary previously, like the way we define parameters dictionary, we can in a similar fashion define metrics dictionary. This metrics dictionary can have something like accuracy, and since I have already added one accuracy, so I would like to rename this accuracy as accuracy 1, and let's put it as 80. And here I would like to pass this metrics dictionary, and let's run this. This time it won't throw. One second. I see. I think this is not allowed. Let's rerun this. Okay, so this time it did not throw an error regarding the run ID, because this run ID we already made sure that this exists, and now that this run with this run ID exists, we can go ahead in the UI to see the output. So we see the metrics appearing here. We have accuracy and we have accuracy 1. Sweet. Now let's move on to logging some other bunch of stuff. The third possible things that we can log is artifacts, and artifacts would be appearing here. Okay, so you see currently we have only one experiment being listed here, because there is only one artifact so far we logged, and that is lecture1.py. But now let's try to log some image. Okay, and the main thing is that to log any artifact, the interface remains same, and the interface is that MLflow.log artifact. Before logging the artifact, you need to get the artifact path, and that artifact path can come from anywhere. For the time being, let's assume we have some training job which is running for some number of epochs, and we need to look at the learning rate progression, or maybe loss progression. So I can say something like loss graph machine learning. Okay, So what we can do is we can grab this graph and we can save this image in the directory where we are having this project, and I can call this as anything that I want for now. So we have this images.png. Okay, so now I can do images.png and I can log this artifact. So let's log it. So a lot of things will change after this. First, if I open ML runs, you will see two directories, two subdirectories are appearing here. The first directory is the previously created experiment, and second one is this one, this YouTube tutorial. If I open the second one, you will see 890, and 890 is the run ID. Inside it, we have images.png. This is exploring, this is basically viewing the artifact within the directory, within the store. We can view the artifact here also. If I go inside the artifact and if I click on this, you can see this image appearing here, and we can zoom in again. So this was about logging artifact, and you are not limited in the manner you are limited in logging params or metrics. In artifact, you are free to log whatever you want, but this power should be used very cautiously, because just because you have the ability to log anything, you should not misuse your storing server. Whatever storing server you are using, currently we are on our local directory, but you might be given access to a object storage in a cloud platform. You don't want to misuse that. Okay, so there are some, although I personally think that these three covers most of the stuff, but there are some other cool things that you can do. So for example, log image is one such thing. If you see, this logs image in a image ND array. If you have worked with deep learning based on images like CNN, you might already be aware that a image can be represented as an ND array. So that array you can directly provide here. Okay, so you can log that like this, or you can save that image, or log it separately. Okay, and then there are other methods for logging tables as well, such as log table. Inside it, you can pass the data like this. So you can either pass a data frame. Let's create a data frame really quickly, and let's see where does that appear. So import pandas as PD, and let's create a demo df. PD dot data frame, and inside here, let's create a data frame with only one column called name, Daniel, Sam. Okay, so now I can log this df. Let's see, what do we see? What do we get? It says artifact file, which means we want to provide the artifact file name also. Let's say I want to name it as demo.df.data. Okay, let's see what, which means when you go inside the UI, it will be appearing in the path that you specify here. Invalid artifact path. Please ensure the file you are trying to. Okay, JSON. Let's provide JSON here. Okay, so if I now go inside here, you will see demo.df.json, and you see this table appearing. Okay, so you, in this way, you can see that you can possibly preview also data. So if I click on these tables, I can possibly preview. I can sort it out if you have very large tables. So let's do one small project. Let's load some large data here. Let me download maybe Titanic CSV. Okay, so let me grab this file and let me put it inside the, and now let's go inside here and let's read this Titanic df pd.read csv titanic.csv, and inside log table I will pass the Titanic df titanic.json. Okay, let's run this. It should be able to log, and now if I refresh it, we should be able to see our titanic.json. But this time this is taking some time, and you get this nice looking table which you can obviously click, and you can sort it out, sort the whole table. You can sort, so you can do really cool stuff, and not all the rows are loaded. You see, there is this pagination option with which you can move through various rows to view it. Okay, all right, and you can also choose columns if you go for compact view. Okay, so these are different options that you get out of the box from the log table. I think that would be it. There are other options also. So for example, if I show you MLflow dot assessment, so you can log assessment also, and assessment would take a trace ID. Now this becomes important when you are dealing with let's say Gen AI based applications. So we have got figure. Now figure is similar to image. You have to pass a matplotlib based figure object, and that will be basically rendered in a artifact here. Okay, so there are multitude of options that you get in MLflow based logging. So I'll stop this video right here, and then I'll continue with next topic, that is model registry. Hi everyone. So in this video, I want to start talking about logging models. Now models, if you are experienced in machine learning, you might be aware that models can come in various flavors. You can be building models in sklearn or PyTorch or maybe TensorFlow. All these different frameworks have their own set of requirements and dependencies that you need to keep in mind before you actually log the model. Now, there could be a manual logging step or a auto logging step. There are two different ways by which you can log, and in this video I want to show you the manual model logging using sklearn. So let me create a new script called lecture5.py. Inside this script I will, or maybe let me grab some training scripts from the MLflow quick start, because that will make our job a lot easier. So we have got this this training data, this training script from MLflow documentation, and let me also grab the train model. Okay, so you see this auto log, so they have enabled it. For now, let's comment it out and let's run it, and let me also confirm if my server is running. Okay, so let me now go in the tracking server. I think it would be 127. Yeah, so this is the tracking server we have. So now let's first of all run it as it is to see whether we are getting any error or not. Okay, so let's see. It's running. Let's see why it is taking so much time. Not sure. 1 second. Okay, so it's saying it's got unexpected argument called multi-class. Why? Let's comment it out then. Yeah, so now our model is being trained. But where exactly is this model? We don't know yet because we have not saved it somewhere. Let's create an experiment. MLflow dot set experiment sklearn model logging. Okay, and inside it, let me start a run, and let's move these training lines within this. And now what we can do is we can also name this run and also log this params. Run name would be sklearn model logging. So this run name is sklearn model logging, and now what I can do is I can do MLflow dot log params, and inside it I can pass params. Okay, so how do I log this sklearn model? What I can do is MLflow dot log model. Okay, no, sorry. I need to call the flavor first. The flavor is here sklearn. So sklearn dot log model, and inside it first argument will be sk model, and the sk model is lr, and second argument will be model name, and name will be, let's say, simple model. Okay, and let's run this. Okay, so our run is complete. Now let's move to check whether our UI has been updated or not. So we have got sklearn model logging, and inside it you can see our params are listed here, and logged models. Inside logged models we have got this, and model name is simple model. If I click on it, so this basically shows us models. Okay, now if I go inside the ML runs and open the third experiment, and third experiment corresponds to sklearn model logging, then I will see a models directory. Now this models directory is corresponding to this model ID. Now model ID, so this model, this simple model has this model ID. Okay, so that's how it is basically able to reference it. Now once this model is logged, we can do all sorts of cool things, such as I can register this model. Now there is a difference between logging a model and registering a model. These two are entirely different things. Logging a model just means you put it inside a dump, in a repository or in a storage. Registering a model means now you can use that registered model to actually deploy to a HTTP based endpoint that is supported by MLflow. So far we have seen that how we can use this to kind of get a manual logging. Let me now copy this, and inside here I will name this as auto. Now this time I won't be logging anything. I will just be training the model, and MLflow will auto detect all the required parameters, matrices and all, but I'll just need to enable the auto logging feature. Let's run this script now. So after run has been completed, it will take some time because it is generating some metadata and some graphs and all. So let's go to, okay, so now I have got, one second. So now I have got two runs. You see auto and logging. So let's open auto, and inside auto you see several different arguments like parameters. Now where are these coming from? These are coming from MLflow's backend compatibility with sklearn. So it is able to detect all these automatically. We have model metrics, we have system metrics, we have traces and artifacts. In artifacts we have we have training, confusion metrics, etc. Now what I can do is I can go inside the logged models, and inside the model I can see a similar structure. So ml model conda yaml model pickle. So model pickle is the actual binary, and all these are just different ways to manage the dependencies, such as requirements.txt, python env.yaml, MLflow, etc. So that's how we do manual logging with a flavor of sklearn, and also that's how we do auto logging with a flavor of sklearn. The process remains same for other flavors as well. The primary thing that you need to know is how to locate your desired artifact. So for example, here I see models. I've got two models. I've got this run, which was created when I enabled the auto log. I hope it makes sense. Next we will cover model registry. Thank you so much. Hi everyone. In the last video we talked about how we can take the registered model and deploy it. Now I would like to switch gears a little bit and talk about some of the cool capabilities of MLflow that make it really exciting to use. In this video, we are going to be looking at nested runs in MLflow. Let's see what do they mean. Lecture 7.py. I'll just quickly import MLflow. I will set my experiment as nested run demo, and we will get started with the creation of nested run. So the idea behind nested run is that there would be a parent run. Okay, let's create a parent run first. So MLflow dot start run, and inside here I will call this run name as parent run. Okay, and we can also alias this context manager just like we do it while opening a file. So as parent run, we can print its information, parent run, maybe parent run dot info dot run id. Okay, and then within this we can, so let's first log the, so MLflow dot log param theta, and let's say 100. Okay, let's create a child run within this. I can specify the run name as child run 1, as child run 1, and here I can print Control C its properties, child run, and here inside here I can specify child, and I can copy paste it multiple times to create multiple child runs. Okay, so I'll say child run 2, child run 3, child run 2, child run 3, child run 2, and child run 3. Now let's run it, although I can also log things, but let's just run it the way it is right now. Okay, so we are getting some error. Let's see where exactly is the error. It's saying run with, okay, so I think we need to provide the parameter as nested is equal to true. Nested is equal to true. One second, not here, sorry, not in the parent. So parent run was created, but since parent run was active, child run, we could not create child run. Let's print, let's pass the nested is equal to true, and let's use nested is equal to true here as well. Let's run this one more time. Okay, so you see this parent run, child run, child run, child run. So this is how it is done. Let's look at it in our UI. So nested run. So now I have got parent run. This was the earlier one, and you have to understand that names can be duplicate as well. So if I expand this, click on this plus icon, you see this child run, child run. Now what would be the ideal scenario where we can potentially use this feature, where let's say one run can correspond to a larger feature, and then multiple nested runs can correspond to something more specific within that. One example that people often use this nested run feature is for hyperparameter tuning. So that is one of the use case that you can potentially go for. So yeah, so that is what I wanted to demo. I'll see you in the next video. So now that we understand how to log sklearn based models, it is right time to introduce a new MLflow concept, and that is MLflow model registry. From the name itself, it should be very clear, but at the same time I feel that MLflow model registry name is not very appropriate, and I will tell you why I'm thinking this way. Because when you think about registry, you often think and associate registry with a storage, right? But that's not the case with MLflow model registry. It is not a store, although we call it as a store, but it is just a store for metadata. Ultimately, your models will keep staying inside the artifact store, which for our situation is our local directory. Whereas what model registry essentially means is it keeps track of your model's lineage, versioning, and aliasing. So there are things that you would want to do with your best model, maybe deploy it into production, or maybe you would like to see which run produced it and things like that. That is enabled by MLflow model registry. So it essentially is a centralized model store, although there is no storage component in a model registry. It is just it just creates this registry using a YAML file. Okay, and that YAML file points back to the backend and artifact store. Okay, so let's see how can we register the model using Python or maybe UI as well. So let me go here and let's see. Let's assume that I want to register this model. The only thing that I need to do is I will come here. I will select the model. So I have to basically create a model first. Now what exactly I'm doing? You might be confused here because we already have lots of models that we trained in our last discussion using auto logging and manual logging. But what exactly we are creating? We are essentially creating a registered model here. Let me go here. Let me come in models. You see, currently there are no registered models. Let us create one. Let us create best production model. So if I create it, there are certain things which will automatically be created for this model. One important thing which is its version. So if I come here, you see currently it is having no version because we did not associate any model to it. Okay, so let's see. Let's go in the experiments again. Let's come here. Let's come to the auto logging, and let's come to the let's come to the models. Now this model is from the logged models, not registered models. So if I click on it, now if I click on registered model and if I click this drop down, I see this option best production model. If I register it, my model will be registered. And now if I check the version, it says version 1. But let me do one thing. Let me come into the experiment. Now, let me go inside the logging, simple model, register model. Now, if I select that same model, what will happen? Let's see what happens. You see, it has incremented it to the next version, which essentially means this is a very good tool when you are building and pushing models into production. So if I open this, you have got two versions, and I can click on various versions. So I can maybe click on version 1 and I can look at its schema. Now this schema is automatically inferred by its input and output. How does that work? Because it is created using MLflow. That is why it is able to, the MLflow is able to infer its input and output schema, essentially the shapes and all. Okay, now what I can do is I can come here, I can add tags to it, I can add aliases to it. Aliases would help when, let's say, I'm deploying the model as HTTP based server. Their aliases might help. Okay, so for now, the basic idea that you have to take is you can register a already logged model, and that gives you some additional features such as versioning and lineage for the model. Okay, now the question is, can I do that via my code? Yes, we can. In fact, when you are logging the model, so let's say in auto logging you can't do it, but if let's say I am doing calling this sklearn.log model, inside here I can pass sk model and then name, some dummy name, and then I can pass something known as registered model name. The moment I pass something like this, now the moment I run this code, let's run this. Okay, let's say my model and registered model, and let's for the sake of it, let's use the same name here, and let's run this. Okay, I'm running this lecture 5 only, and let's see what happens. So we are also using its auto log facility, and we are also logging the model by default, manually, sorry. You see, registered model exists, hence it is creating a new version. So if you refresh it now, you have got version 3. I hope you are able to understand how model registration works. Okay, so I think that would be it for this video, because model registry in itself is not a very huge topic. But now in the next video, we will be taking up this model, and we will be trying to access it via HTTP based server. Okay, let's get started. And I think in the next session, I will also have to talk about model URI. Essentially, I think I can do it right away. So model URI is essentially a unique identifier that you can use to reference a registered model. Okay, and the way you do it, this is models / model name. Now here my model name is best production model, and then model version. That's it. So this is the model URI that you can essentially use when you have to, let's say, deploy a model. And in fact, we will be looking at how we can do that as well. We can also reference a model using as runs syntax. So I can have something like runs, the run name, and then there will be the model name. Okay, so let us see these various examples in the next video where we deploy these models. Okay, thank you so much. So in the last discussion, we talked about how to take your models which are logged, which are hidden inside a run, which are stored within the artifact store, and take those model and put it inside a separate store, which is essentially referring to the same thing, but now with some enhanced metadata. Registered models are just the same model, but with some additional metadata tags, which helps in organizational and operational aspects. In this video, we will quickly look at how to take those registered model, or any model for that matter, even those which are logged within the run, and deploy it using a HTTP based endpoint. You might be wondering or maybe worrying that I don't know about Flask or maybe a fast API. How can I do that? The answer is you don't need to know any of those things. How can you then run a HTTP based server? Just open a new terminal, activate your virtual environment, and run this. MLflow provides a utility called model serve. Now, after this serve, you need to provide some arguments. The first one is M for model. In the model, you want to specify the URI that we discussed in our last discussion. The URI follows this format: models, colon, /. Let's go to the registry and let's grab the model's name. So best production model, let's grab this and let's paste it here. And we also need to specify the version. So let's use the second version. After that, we need to use the port. Port, we can use anything. Let's use some random port. I don't know why. I don't know how I came up with this number, but yeah. But sometimes what happens is I use some random ports and there is already an existing service using that same exact port. And in that situation, MLflow will throw an error. Finally, there is this argument which you need to specify if you are not willing to serve this model using container based setup. So I'm specifying no conda. If I run this, it will it has basically started this process, and it has started a server on this URL. Now this URL by default exposes several endpoints such as invocation, health, etc. Let's try out this. Let's curl into it. Let me grab this URL first, Control C, and let me paste it here. If I hit enter, it says not found, but let's call it health. In health, it does not return anything, but it is not also giving us any error. There is one in particular endpoint, that is invocation. Invocations. Yes. You see, method not allowed. So it's saying this method is not allowed. Why? Let's see. One second. Let me expand this. Okay, it's saying 405. In the health, it said 200, okay, but in this, it is saying not found. Why it is not able to find? Because invocation is the one that I must have misspelled it. Invocations. Why? Okay, let's pass the argument. I'm not getting why it is not accepting our request. Content type application JSON, and we also need to provide data. In the data, I'll wrap this data in here. Let's pass inputs. Inputs would be a list of all the rows that you want to get the prediction for. Yes, you see? Okay. So method was not allowed. Somehow, when we don't pass data, it simply does not return. But let's see. If I remove this 4, it will give this error that X has 3 features, but logistic regression expecting 4 features as input. So our model was trained. Now, where did we set up this? Let's look at this. When we created this data using make regression, if I recall correctly. Oh, no, load iris. So this is what we used, and inside here we have 4 features. That's why it is requesting for 4 features. Okay. So that's it. That's how you basically set up a HTTP based model server using your registered or logged models. Now, this is very simple actually, right? But this kind of setup is only ideal for real-time inferencing, or in ML system terminology, it is known as online inferencing, where you deploy this REST-based API into a Lambda function or maybe Azure functions, and then you start accepting some requests, and then you serve those requests on the go. Okay, but for the batch-based requirements, you might have to create a script and call load the model, and that batch setup. How we can do? We can load the model using sklearns dot load method. Let's try it out. Okay, so let me now create a new script maybe, and inside it I'll just import MLflow, and I'll say MLflow dot load dot sklearn dot load model. Inside here I need to specify model URI. So let's use this same model URI that we just deployed. One second. Okay, so this is the model URI that we basically chose. So let's grab this, and I'll say model URI, and inside here I can pass this, and what I will get in return is a MLflow model, which I can use for batch inferencing. Okay, let's run this script. Just 6. Okay, so you see it is printing logistic regression, and that's what our model is. Now we can use this model just like we would use a normal sklearn model. Okay, so this is how we load a already registered or logged model for our batch inferencing workloads. And for real-time inferencing, for online inferencing, we just spin up this nice looking server. I hope it is making sense. Hi everyone. In this video, we are going to be taking a little detour from our traditional ML, and we'll start talking about GenAI based MLOps experiment, or rather we should call them as GenAI ops or LLMOps. You can call it whatever you want, but the key thing is to master the fundamentals so that whatever the outside world calls it, you know what you have to do. Okay, so the first topic that we need to cover is how does GenAI ops differ from traditional MLOps. Now in MLOps, there is this thing called machine learning model that gets replaced by prompts in LLMOps, because essentially what you have to do is, just like models can be random, models can be can not be very deterministic, they are probabilistic. Just like that, prompts can also be probabilistic. It's very simplistic explanation, I know, but it gives you a clear difference between GenAI ops and MLOps. So LLMOps, in LLMOps, we need a way to manage prompts, just like we had to manage models in the MLOps. Now, to manage models, MLflow provided you with the model registry, and you must be guessing it right. To manage prompts, MLflow is providing you with the prompt registry. So let me quickly start the MLflow server and show you what exactly I mean by that. So let's open Chrome and open this server. Okay, so you see these prompts. If I go here, you will see some prompts which already got created when I was playing with this concept in MLflow. But we can come here and we can create prompt. Okay, we can provide the name of the prompt. We can choose the type of the prompt, whether it is text based and chat based, and I'll show you what exactly both of these mean. I will provide the prompt. I will provide the commit message. So essentially what happens is, you get to version your prompts. You can create multiple prompt versions. So suppose we are building a question and answering or frequently answered questions FAQ bot. Okay, we are building FAQ bot and we are trying to optimize and create the best prompts. So how can we go about it? So we have named this prompt as FAQ bot. Now under it we can basically define what is known as prompt template. Now that prompt template will be replaced by the actual variable that we need to inject within the prompt. But let's start with the text based prompt and I'll tell you what chat based prompt looks like. Or maybe I can show you. In chat based we can have, similar to how we call OpenAI's API, we can have various type of roles: user based, system based, and assistant based. And for these roles we can basically have different sort of you can say messages. Okay, so let's go with text based prompt and let's write it down. Okay, so you are a helpful assistant who answers the provided question concisely and precisely. Okay, so this is the prompt, and now let us write that the question will be here, and here we will write the placeholder as suggested by MLflow. We will write question as the placeholder. Now later you will see how we can replace this question, but for now we are just creating prompts. We are not seeing how we will be basically loading this prompt and passing it to OpenAI or whatever LLM you are using. I'll use the commit message to basically track. So version 1. Okay, so let's create it. So we just added a new prompt and it is a version 1 prompt. Okay, all right, so it is a version 1 prompt. Now what is the next step? Next step would be to basically try out this prompt and evaluate it. We can evaluate it, or we can evaluate multiple prompt versions. I can create one more version of this prompt. So you see this same prompt appearing because I can edit it now. So I can say something like answer the question only in English. Second, answer should be under 3 seconds. Oh, sorry, 3 sentences. Okay, and that there are more things we can add, and if I can create it, you will see version 2 is added. Okay, now I have the ability to compare prompts. So if I click on compare, automatically these two versions are selected and we see color highlighting of what is added in the version 2. If let's say I have got one more version, then I will get the ability to select one prompt for the comparison with the another one. Okay, so this is how MLflow is providing you with the prompt management, or rather I should say prompt registry, just like it provided you with the model registry. Now what you can do is you can create and load these prompts through Python SDK. You can actually, so what the process that I showed you from UI, you can replicate this exact process through the Python also, and I'll show you that in a moment. Okay, so now let's try to create a prompt just for the sake of it to show the demonstration. So I will create lecture 8.py and I'll create a new shell here. And here let's import MLflow, and inside MLflow let's define prompt version 1. Now this time I won't be touching this frequently asked questions bot prompt. I'll be creating a new prompt. So let's get started with that. So prompt version 1 would be, I will create a new line and I'll probably escape the first one, and then I'll write you are a helpful, or maybe let me grab this entire thing because I should not be typing it right now. Okay, so yeah, so this is my prompt. Let me get rid of this. So this is my prompt version 1. Now what I can do is I can do something like MLflow.genai dot save. Let me type prompt. I think it was load prompt, not load, register prompt. Sorry, register prompt. So inside it, we have to pass name first. So name would be what? Just like this, I can have frequently answered question bot. Now, if I use this same exact name, what MLflow is going to do is it will register one more version. So that's why I will be. So it's just like MLflow models. I will be using first, and next we can provide the template. Template would be this string. Okay, and we can provide commit message here. Commit message, the way we provided message in the UI, we can provide it here also. Version 1 prompt. Okay, now if I run this, we should be able to see our prompt in the prompts. So you see frequently answered question bot 1 that we just created, and we are seeing this prompt, right? Okay, so what is the next step? Next step is going to be loading the prompt. How can we load the prompt? Now obviously I want to get rid of this now. Okay, so let me maybe comment it out for now. Now suppose you are working in an organization setting where maybe, I don't know, 100 of people are working on a project, or working as a data scientist or Gen AI specialist, and they are all trying out their own prompts. And prompt building is much more easier, I would say, than model building. So hence prompt can be built not just by data scientists, but can be built by other folks, maybe product specialists or maybe managers. So there will be a lot of prompts appearing, and MLflow can provide a centralized place where all those prompts can go. Okay, and they don't need to do it through Python. They can create a prompt from here as well. Now suppose you know a given prompt is best one performing. For now, let's assume that we know uh, from our experience that given prompt is working best. Now how can we go about actually loading the prompt? And finally, after loading the prompt, we should be able to use it also. When I say use it, I should be able to use that prompt and pass it in a LLM, and I'll show you that in a moment. So let's try to load this frequently answered questions bot using Python. So how can I do that? So I'll do something like MLflow dot GenAI dot load prompt, and inside here I need to provide name or the URI. I can either provide the name, that is this, or URI. And URI follows just like models. It follows something like this: prompts, the name of the prompt. So if I use the name here, and then version. Let's load the first version for now. After loading the prompt, what I can do is I can save it in a variable. Now let's try to print it out. How does it look like? Can you try to guess how will this prompt be looking like? Let's see. So if I run this, so this prompt is looking something like prompt version, name, version, and template is only given. Some characters of templates are displayed here. Now how can I actually use it? So what I can do is I can call prompt.format. Now inside this, I can provide all the placeholders that I have used here. So let's pass questions here. How is the weather like? Okay, so now what do you think will happen? Let's run this. What it will do is it will take my prompt and it will inject this question variable that I passed. So prompt.format question. So you are a helpful assistant who answers the provided question concisely and precisely. Question is, how is the weather like? Now let's extend this, and let's register one more prompt version. So let me comment this out first. And this time I'll be using frequently answer bot 1, the original one, and in the prompt version 1, or maybe I can rename this to version 3. In place of question, I would want one additional variable passed here. So what can I pass? Username. Okay, user name. Okay, now what I can do is, first of all, I need to register this prompt. Let's register it first. Okay, if I reload this now, I will have this prompt, which also expects a username. Now let us comment out our prompt registration code, and let's uncomment the prompt loading code. So now, besides the question, we need to pass the username, but let's see what happens if we don't pass the username. Okay, it basically, okay, no, sorry, I think I need to change the version also, no? Okay, so it says this, that is missing variables. Now what I can do is, I have two ways to solve this. Either I can provide a user name, let's provide Rahul, okay, and let's run this. It should solve the issue, right? Or, so, and Rahul. Or what I can do is, I can get rid of this and I can do something like allow partial is equal to true. In that case also, this will solve the error. So here, okay, one second. Yeah, so in here what happens is, what you get now from the prompt is not the text but a prompt version only. So it was not able to render it properly. Okay, so I hope you are able to see how we can load the prompt. But now let us see how we can actually use the prompt. That we will be seeing in the next video. So in this video, the purpose was to show you how prompt management works and how it is similar to model management that we already are familiar with from our earlier lectures. In the next video, we'll be talking about how to load the prompt and also use it with, let's say, OpenAI's API. Thank you so much. So in the last lecture, we looked at how we can manage prompts using MLflow. Now, what we are going to do is, we are going to use OpenAI to actually use the prompt in a real production setting. So first you need to basically make sure that your LLM's API is installed. So I'll install OpenAI's API, which is already installed. After that, you need to somehow save your environment variables, and in particular what the variable that we want to save here is called OpenAI API key. So this is the environment variable that you need to save in the environment. Now, how can you save it? There are multiple options. You can use export by coming here in the command prompt, but I like to load it. I don't want to modify my my system, my computer's environment variable. So what I usually like to do is, I load the environment from this file called .env. Now this .env I won't be showing you in this video, but this contains a key called OpenAI API. What I can do is, I can use a Python package called .env. So from .env, I'll import load.env. Now what load.env does is, so when you call load.env, it will ask you for the path of your .env file, which exists in the same directory from where the script is going to be run. In that case, you don't need to provide the path. But after this, you can access your env files. But for that, you would need to import the OS package. So what happens is, when you run this script, a new process is run, and that process will have its own set of environment variables, and what this load.env does is it will inject any environment variable that it sees in this .env into the uh, into the uh, into the current process environment variable. So I will get env OpenAI API key. Okay, and this will provide me the API key of the OpenAI. Now what I can do is I can create a client. So let's import the OpenAI client from OpenAI, import OpenAI, and I'll import the client which is going to take API key, API key. So now my client is ready. So now that I have this client, I can use it to ask questions. Now I will be using prompt version 1 that I had, or maybe let's use 2 because 2 was the better prompt. Let's see. Let's go to UI. If I go, yeah, so this was the better prompt. Let's although I cannot objectively say that this prompt is better because I'm only subjectively saying. How can I objectively say that a prompt is better prompt? Is by prompt evaluation. That is a separate topic which we can take care in some other discussions. But here, from visual look, the way humans interpret it, it's more detailed prompt. So it should give us the right answers. So let's go here and let's load the second version of the model. And I will now load the message. So I'll call prompt.format and I'll ask a question. Let's ask some question. What is or maybe I am not able to think about any question. So what exactly is the difference between sun and moon? I'm not sure. This is not a very good question. Okay, sun and moon. Okay, so now what I'll do is I will also print this message just to see whether it is looking good or not, and let's run this. So you are a helpful assistant who answers this. What exactly is the difference between sun and moon? So we have the message. Now what we can do is we can use the client.chat, and in fact if you want to use responses API, that's also fine. It's better, I feel, but let's go with chat completions because I feel the coverage of chat completion is more at this moment. People are moving towards it, but still it is not very uh, prevalent. So I will be using a mini model, and then I will use messages, and inside messages I'll create a list where role would be user, and content would be my message that I created from the prompt. Now I will save this in response, and this response I can print. I can either print this response or I can print the content. Let's first try to print the sorry, not message but response. Okay, so let's try to print what do we get. So it's taking some time, and we are getting the chat completion. So if you see, the sun is a massive star that produces light and heat through nuclear fusion, while the moon is a natural satellite that reflects sunlight. So I think pretty good, right? But if I have to get this text from here, so how can I do that? So what I can do is I can get my response dot choices. I'll get the first choice dot message dot content. Okay, so let's try to use that now in place of response. Okay, let's run this. Now currently remember that we are not logging these things like responses. That is a topic of separate discussion because this the logging of both inputs and outputs in MLflow is going to be called as traces in MLflow, but we will be covering that in some later video when we start discussing the evaluation, prompt evaluation. So you see this is what is being returned by the OpenAI. So I hope it was clear. So in this video, we try to look at how we can use the prompt. So this prompt registry is a centralized place to create and manage prompts. And from there, we can use and try out a bunch of prompts. Currently, we have not seen how to evaluate prompts. That we are going to see in next videos. Thank you, everyone. So far we know how to register a prompt within the prompt registry, MLflow prompt registry. And we also know how to load those prompts for our consumption. And also not just load, we can basically format those prompts, because essentially what we register in prompt registry is going to be a template, and then we can load those templates and use it within the LLM. Now, next thing is the way we evaluate models, we can also evaluate the prompt. So let's see how can we do that. So let me create a new file for this. And in this file, I'm going to keep all of this code. Let's keep this code. Okay, so we are going to be evaluating some prompts here. How can we do that? So let's go backwards. Let's first see the exact function from the MLflow that we use to start the evaluation process. So what happens is, when you run the evaluation process, a new run is created. When I say a new run is created, what it means is that run will be tied to one experiment. So similar to how we track a MLflow experiment, we can track a LLM based experiment. So let me start an experiment first of all. So I'll set an experiment. Maybe I'll say prompt evaluation. Prompt evaluation. So currently, if you see, let me go to the server. And if I refresh it, and if I go into the experiments, we have all sorts of experiment, but we don't have prompt evaluation experiment. So let's run this file, or maybe I will comment most of this code so that not this one also. So let's keep these things as they are. Python lecture 9.py. So after this, we will have experiment with the prompt evaluation does not exist, creating a new one. If you see this line. Now if I go inside here, you see prompt evaluation. Now within this prompt evaluation, so this MLflow view provides two different kinds of view. It can, so if I click on it, notice what happens. It will ask me what kind of experiment you are dealing with. You are dealing with machine learning based experiment or Gen AI based experiment. Since this is going to be a Gen AI based experiment, I'll confirm, because model based experiment, traditional machine learning based experiments are going to have different artifacts, different set of things than Gen AI based experiment. As we discussed earlier, in Gen AI based experiment, prompt is something similar to model. So it has different set of constructs than a machine learning based experiment. Let me confirm this. And if you see this view, and also to compare this, if you don't recall already, let me open a sklearn based experiment. This looks different, right? So this has runs, models, and our experiment, which is a Gen AI based experiment, will be looking like this. It will have traces, sessions, data sets, evaluation runs. Currently, we don't have any evaluation run because we are going to create one. Okay, so after we do that, let's first of all look at the function that we use for the evaluation. So there is this function called evaluate. Now let's see what all things that we basically require to pass, because we are going to learn those in a backward like fashion. So first we see the evaluate function. So let's use the data. Okay, so we have data, we have scorers. Okay, and then we have predict function. Okay, so these three things would be required if you have to run the evaluation job. Now let's talk about the data first. What is a data? Now, similar to a traditional ML ops, if you have to evaluate that machine learning model, you need a data set, right? Similar to this, here also you would need a data. In the traditional machine learning, with your x and y's, you will also have to have the predicted value. That is how we can compute accuracy or F1 score, things like that. Here also we would need to have some sort of expected response. So this data will be a list, and this list will be essentially a list of, you can say, dictionaries, and each dictionary can have inputs. Okay, and let's talk about what input can contain. It will have a expectations, because there are no. So basically expectations means what would be the right thing for this right answer for this kind of input. Okay, after expectation we can optionally have outputs as well, but since we are passing predict function, we are delegating this to the to the GenAI to the GenAI dot evaluate to basically call this function to generate output. So this list can contain as many test cases as you wish to basically include. In the inputs, you would like to have a key. Now, what sort of key should I have here? That depends. That depends on what sort of predict function that you will be having. So let's design the predict function first. What my predict function is going to do is, it is going to take a key. Okay, let's take a questions key, and this particular this particular function is going to essentially return an output. Now what will be the output? Let's design that. Okay, so what we are going to do is, we will take this code. So essentially we will load the prompt first here. Okay, we will load the prompt first, and before even before even formatting the prompt, we will have to load the prompt, right? So from here I will load the second version of prompt. Okay, so I load the prompt, I format it, and I don't print it for now, and then I will call the OpenAI client API. Okay, so after I do that, let's see. After I do that, I basically assign the output. Output would be what? This, right? Okay. So now we have the predict function ready. Okay. So now I will write the predict function here. Okay. Now let's come back to the data. In the inputs, I want to specify that key which is used in the predict function. So I will use the question key here. And in the question, let's ask the question here. Let's say, what is the who invented maybe I don't know who invented telephone. Okay. Now in the expectation, I will write something like expected response would be. So let's see who invented, because I don't know who invented. I think somebody Berners-Lee. I don't know who invented telephone. Okay, Alexander Graham Bell. Okay, no, Alexander telephone. Okay, so I'll copy this and I'll write it here. Okay, so let's go with this first. Okay, so we have input, we have expectations, we have expected response. Now we can come here and we can write the data. Okay, so the only missing piece now is scorers. How can we basically create scorers? So this scorers would be a list of all the different type of scoring methodology that you would like to use to evaluate your answers. You can write custom scores, but for now what I'll do is I'll use the inbuilt MLflow's inbuilt correctness scorer. GenAI.scorer dot scorers dot correctness. Okay, so this is one scorer that it offers. Now this correctness scorer is a LLM based driven scorer. So let me pass it for now, and let's run this experiment. So now if I run it, what it will do is it will, under this experiment prompt evaluation, it will create a run. Let's run this and make sure it is successful. So you see this to disable. So currently you see this progress bar. So it is running some validation. So you see evaluation complete, metrics and evaluation results are logged. Let's go here and let's refresh it. We should be able to see this run. So if I click on it, we see this trace, and if I click on it, on the right I see some sort of correctness evaluation. We will look at what those things mean in the next video. I hope you are able to understand so far how to set up the evaluation with MLflow, but we will do a deep dive and look at other ways by which we can evaluate write these evaluations more in depth in next video. Thank you. So in the last video, we discussed about how to set up a prompt evaluation function using MLflow. Now in this video, we are going to deep dive into what exactly is the output of that evaluation. So what happens is that once that evaluation is complete, you get a new run. Inside that new run, you will get traces for each of the data inputs that you provided. So for the first data input, if you see, if I click on this trace, so you will get two things here on the left, inputs and outputs. Input would be the prompt. So you see, you are a helpful assistant, and then this is the exact question that was, one second, I think something is not right. One second. Okay, I think I did not use this question. So let's do one thing. Let's in place of this use this question and then run this evaluation again. So let me close this, and there will be new run that will get created after this. So you have to watch out this evaluation. So currently this evaluation is running. It takes some time because it takes help of LLM to basically do this correctness test. Okay, so if I refresh it, you see a new run is created, and if I click on it, you see again there are inputs and outputs. In the inputs, you see you are a helpful assistant. All these things have been extracted from our prompt template, right, that we created earlier. That prompt template exists in the prompt registry, if you can navigate there. So if I open this FAQ bot and I'm loading the second version, so this is the prompt template that we are loading, and we are replacing the question. So if I go back, I'm replacing the question, who invented telephone, and that question is coming from our evaluation data set. I can call this this as eval data set, and this as eval metrics. Okay, so correctness is something that we are measuring. Now what is the output? Output is the output by the LLM model. Now we need to navigate to here. Alexander Graham Bell is credited with the inventing of telephone. Now why it was so concise? Because in the prompt we basically asked the LLM that you need to answer the question only in English. Answer should be under 3 sentences, and that is why it respected that. Now on the right you will see navigation, not navigation, on the right part of this screen you will see assessment. There are multiple assessment, only one assessment for now, correctness. I can expand this correction. It is saying yes, it means it is correct. The response that LLM has given, it is correct. How it is correct? It is basically following our expected response. Okay, so the claim states Alexander Graham Bell as the inventor of the telephone. The document explicitly states that this is credited with inventing the telephone. Now let's do something dubious here. Let me run this evaluation again, but here let me, so I'm kind of tricking the LLM to give the wrong answer, to basically fail this test. So let me do something like, let me write here, I don't know, Isaac Newton. Okay, so I'm doing this for fun, but let's see what happens. Okay, so who invented telephone? Isaac Newton. Now our evaluation is being run. So this is our expected response based on our ground truth. So ground truth itself is wrong, but let's see what happens. So if I refresh it, we have a new run and a new trace. And each trace will correspond to one data. So you see no. Why? Okay, let's expand this. Let's see the rationale. Questions ask who invented the telephone. The document clearly states that telephone was invented by Graham Bell, which means this document states that telephone was invented by Graham Bell. Okay, and he was awarded. The claim, however, names Isaac Newton. Claim names as the Isaac Newton as the inventor, which is not supported or mentioned anywhere in the document. Therefore, the claim is not supported by the document. So this is the document that is returned by the LLM on the left, and this is the rationale that it is not correct based on the you can say based on the you can say based on the claim. Okay, so we are claiming that it is Isaac Newton who invented it. Okay, let's go back to that. Alexander Graham Bell. Okay, I hope you are able to understand what this correctness is doing. Now, there are some pretty cool thing that you can do with only inbuilt things. So there are some ways by which you can build your own custom scorers that we can cover right now, but that maybe we will cover in the next video. But let me cover one more important you can say evaluation framework, that is guideline. Okay, so there is one more thing that we can do. GenAI dot scorer, I guess, dot guidelines. Okay, in the guidelines we can provide the guideline name. So suppose I create a guideline such as is professional, is professional, and I can instruct this guideline. So instructions, oh no sorry, guidelines. So I can provide the guidelines. Again, these both correctness and guidelines will be LLM driven. So LLM is acting as a judge here. The answer should be professional. Or maybe let me trick this also, because in the prompt I'm saying it to give me answer in as precise and less than one words. But here guidelines I am saying should be professional and long, maybe really long. Okay, so now it will fail, right? So the reason I am trying to cover this type of situation is I want to show you how this is working under the hood. Let's run this and let's see how the output looks like. Okay, so let's refresh it and see. Okay, so this time a new run is created and let's open the trace. So you see correctness this time is true. Correctness is true. Why? Because in the expected response we clearly stated that Alexander Graham Bell is the expected response for this question. This is the claim. Now is professional. Why it is false? Let's look at the rationale. So it's saying the guideline states that the answer should be professional and really long. The provided response is indeed professional in tone. Okay, what is the response? This is the response. It is professional, but it is very brief and does not meet the criteria for being really long. Therefore, the guideline regarding length is not satisfied. So here in this particular assessment, we are able to see two different you can say correctness. We are able to evaluate this prompt using two different metrics, you can say. One is guideline and another is, now there are custom scorers that you can develop, which we will be looking at in next video. But I think this is going to be it for this video. But before I close out this video, I want to take your attention to one important feature of this MLflow, is that in this tab, if I come to the right, so within this tab, if you scroll to the right, you will see all the assessment and you will see this nice looking graph. Now, currently I have only one data, and that is why you are seeing only one trace, and corresponding to that trace you are seeing it is passed, it is failed, and overall it is going to tell you what is the percentage of pass, what is the percentage of fail. Okay, for each of the assessment that you are doing. Suppose hypothetically speaking, if you have got 100 test cases here, then there will be 100 traces here, and then it will be a real test of your prompt, like how many of those are correct, how many of those are professional, and things like that. Okay, so I can quickly show you what exactly I'm trying to say here. Okay, so I have just added three basically questions here. Maybe first question is, what is the capital of, what is the capital of India? And let's write the answer as New Delhi. And then oldest, what is the, which is the oldest university in the world? Okay, and let's search for our oldest university in the world, and let's write that down. University of Bologna. Okay, so let's write it down as the expected response. Now we will be evaluating Control Z, University of, what is happening? I think I'm not able to read. Control C, Control V. Okay, so now we have got three data points in our eval data set, and let's change it back to being professional only. Okay, and let's run this now. So now you will be able to see the true power of MLflow. So it will take some time because it is going to call LLM for three test cases. So if I now refresh it, so you will have a new run, and in the new run you will have three inputs. And if I scroll to the right, you will see one of them is failing. Which one is failing? Let's see. Our claim is that the oldest university is University of Bologna. I don't know where that university is, but let's see why it is failing. What is the output? It's saying University of Al Qarin, founded in this. Okay, it is failing on the correctness. Why it is failing? Let's think it step by step. The claim states that University of is the oldest university. However, the document explicitly states that oldest. So you get the idea, right? But on the professional, so on the professional assessment is professional. All of them are professional. So this is how we evaluate prompts, but there are much more things that you can do. So for example, if you have to compare two different runs, so let's say I want to compare this salty run to the skillful run. So I'll select skillful, see what will happen. You will be able to side by side see which of your prompts. So it may happen that your next, this run is corresponding to another prompt, and this run corresponds to some other prompt. So in this manner, you will be able to make a side-by-side comparison of both the prompts, and you can clearly, decisively say which prompt is scaling better, which prompt is doing better in correctness and in professionalism. And you can imagine, if you have got 100 of data sets and 100 of prompts, this can be really useful and handy thing. Okay, so thank you so much. In the next video, we will be seeing how to write custom scorers. So far, within our evaluation of prompts, we have been only using the inbuilt correctness and guidelines classes that are readily available by that are provided by MLflow. Now let us write a custom scorer. Okay, so for writing a custom scorer, you need to basically create a decorator function. So let me first from GenAI import scorer. Okay, and let's create a function called custom scorer. Now this custom scorer can basically return certain things. Okay, it can either return a boolean, and it can take various things such as inputs, outputs, and expectations. There are other things such as traces also it can take, but for now let's go with this. We won't be needing inputs here, but let's use outputs and expectation. Okay, so suppose my custom scorer that I want to implement is trying to check for exact match. Okay, so I will say exact match, exact match. And what I'll say is I'll simply say check match is equal to if my outputs is going to be exactly equal to my expectation. Now expectation would be a dictionary, so I would need to extract the expected response. Okay, so I will just return this match one. Let's try to use this scorer. So I will plug this scorer after my guideline. So exact match, that's it. Okay. Okay. So exact match is going to take inputs. Now I'm not using inputs. That's not required. So let's now run this evaluation on the 3 data set. And I'm telling you this upfront that it will fail for all of these, because by default our prompt is asking for a generic answer. It is not strictly telling the model to return only the exact thing. Okay, let's see, let's run and try to see what do we get. So exact match, missing 3 positional arguments. Okay, all right. Why it is not okay, so we are getting 3 positional argument. Why do we need that? Why? Okay, if I provide the exact match just like this, I'm hoping that something is wrong here. Okay, let's see. We are not able to. Okay, so evaluation complete, but let's now go back to the run. Okay, so we have a new, and then in the trace, let me get rid of this first, please. Let's refresh it. Let's run it. Okay, so I have opened this in a new tab. In new tab, you can clearly see. So exact match, it is failing. Why it is failing? Let's look at that. So it says simply false. Why? Because we did not provide any rationale here. But if let's say you have to provide the rationale, you can use something known as a feedback class. So in MLflow, so from MLflow.entities, you can import a class called feedback, and instead of returning this match just like this, you can return a feedback class. Okay, the first argument of that feedback class will be this value, and then a second argument will be rational. Okay, let's come back here. So here we are correctly getting this answer. We are getting a professional answer, but on isMatch we are not getting anything. Okay, let's now do one thing. Let's add one more eval input to kind of see if we can get it to pass the test. So what is, I will ask it a very deterministic and simple answer. So what is 2 plus 2? Tell me just that, nothing else, nothing else. And inside here I will try to just print 4. Now here is the issue, because in expected response we can have something like 4, or maybe we can have a list, but let's run it, because otherwise I will have to change all the expected responses. Let's see if we can get it to pass this test or not. Okay, so we have got 4. Okay, all right, let's refresh it. So we are getting this, and let's, okay, so even this is failing, but let's try to see what was the model's response. Okay, so it has basically given this rationale that 2 plus 2 is equal to 4, and in the test we are clearly saying checking whether output is exactly equal to expected response. But if I, let's say, check it something like this, Control X, you can modify it if expected response in outputs, which essentially means that I'm saying outputs would be a string, and I want to check whether my expected response is in output or not. But let's try to see what happens. Okay, something happened, but let's see it in the UI. Okay, do we, yeah, so we are able to pass all the tests. Okay, so let's open this trace in a new tab. In the new tab, what happens is, here if you notice, if I open any one of the trace and expand this exact match one, I'm able to see that this is passing, because here from the earlier exact match restriction, we expanded it to a very relaxed match, where I'm just checking whether the expected response is there in the outputs or not.